If you've ever been in a stadium when they did the wave, you probably saw that waves have a lot of energy. Of course, a physics wave and a stadium wave are not really the same thing. But as it happens, it's still true in physics. Waves really do have energy. Waves are vibrations in space and time that carry energy. Since they carry energy, understanding how energy and waves are related to each other is pretty important if you want to understand waves themselves. You really cannot separate energy and waves. But what is it about waves that determines how much energy they have? Why does one wave have more energy than another? How do you measure this? To find out, let's talk about amplitude and frequency. The amplitude of a wave is how the wave is measured from the rest position, or midline, to the top of a crest or bottom of a trough, measured in meters. A wave with a large amplitude will be particularly tall, and a wave with a small amplitude will be particularly short. It turns out that the amplitude tells you how much energy is in the wave. A high amplitude wave is a high energy wave, and a low amplitude wave is a low energy wave. In the case of sound waves, a high amplitude sound will be loud, and a low amplitude sound will be quiet. Or with light waves, a high amplitude beam of light will be bright, and a low amplitude beam of light will be dim. But amplitude isn't the only factor that affects the energy of a wave. The other factor is frequency. Frequency is the number of waves that pass by each second, measured in hertz. So a wave of a particular amplitude will transmit more energy per second if it has a higher frequency, simply because more waves are passing by in a given period of time. In fact, in the case of electromagnetic waves, like visible light, radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays, the frequency and amplitude collectively tell you how much energy is stored inside the wave. For example, light is a wave, but it also contains particles called photons, and each of those photons contains an amount of energy that is proportional to the frequency. So high-frequency light has photons with high energies and appears blue in color. Thus, amplitude and frequency are the two factors that affect the energy transferred by a wave, the height of the wave, and the number of waves passed by each second. In physics, we say that energy cannot be created or destroyed. It can only move from one place to another. We call that the conservation of energy. So what we mean when we talk about energy loss? Well, energy might not be created or destroyed, but it can still move to a place that is less useful for us. When environmentalists talk about saving energy, what they mean is that we need to try to avoid energy transferring to places where we can't use it. In the same way, a wave can lose energy as it travels through a medium, because energy can be absorbed by that medium. Distance also plays a role in energy loss. For example, if you have a speaker producing a sound in a large room, your eardrum only hears a small portion of the sound being produced. The sound is produced in many directions, and therefore only some of the waves make it to your ear so you can hear it. Sound spread out from the source, and the farther you are from a sound, the more this spreading effect will cause the sound to be quieter when you hear it. You can imagine the sound is being spread out on the surface of a sphere, and as you move further away from the speaker, that sphere is bigger, so the intensity of the sound is smaller. So the energy you receive from a wave compared to the amount of energy that was actually released will vary based on distance. Waves spread out, and energy is lost. Waves are vibrations in space and time that carry energy. This includes sound waves and light waves. Those waves carry an amount of energy that can be measured. The energy in a wave is determined by two variables. One is amplitude, which is the distance from the rest position of a wave to the top or bottom. Large amplitude waves contain more energy. The other is frequency, which is the number of waves that pass by each second. If more waves pass by, more energy is transferred each second. In the case of electromagnetic waves, like light, each individual photon inside the light has an energy that is decided by the frequency. When waves move, their energy spreads out. This spreading out can cause energy to be absorbed by the general environment in ways that might not be desirable. We call this energy loss. Of course, energy isn't really lost, it just moves to a place that is not useful. Less energy is received with distance, for example. The further you are away from a sound speaker, the quieter the sound, because the sound moved in every direction. It spread on the surface of a sphere, and if you're further away, that sphere is bigger. That's why sounds are quieter the further you are away from the source.